Hello students, welcome back to the lecture. In this series, we are studying class 11th chapter 1, that is sets. And we have completed mostly all the topics. A few are remaining. So today will be the last lecture of class 11th NCERT chapter 1. So let's begin the lecture. In this lecture, the first thing that we are going to study is complement of a set. Now let's try to understand what exactly is a complement of a set. So let U be a universal set which consists of all prime numbers. So we are starting with an example. So we'll try to understand the concept of complement of a set through an example, right? So in this example, what we are doing is we are considering a universal set which basically consists of all the prime numbers, right? So if you want to form the universal set U, so it will be nothing but collection of all x's where x is a prime number, correct? So this is our U. Now A be the subset of U, which consists of all those prime numbers that are not the divisors of 42. So let's try and figure out that what exactly are the divisors of 42. So if I try to find divisors of 42, so it will be 1, it will be 2, 3, then you have 6, then you have 7, then you have 21, and then you have 42. So these are the divisors, out of which, if you'll see, you have 2, 3, and 7 as its prime divisors, right? But in the question or in the example, we are not considering these three because we wanted to form the set A in such a way that it should be a subset of U which consists of all those prime numbers that are not the divisors of 42. So that means we want to form a set A which does not contain the element 2, 3, and 7, right? Because 2, 3, and 7 are divisors of 42 and we are basically trying to form a set which does not have any divisors of 42 whatsoever, right? So here you can see clearly, if you want to write the set A in set builder form, so it is collection of all x's such that x is an element in U because it is a subset of U and x is not a divisor of 42. So in set builder form, it was very easy for us to express A. Now here we see that 2 is an element of U, but 2 does not belongs to A because 2 is the divisor of 42. So we do not want the set A to contain 2. Similarly, we do not want the set A to contain 3 and we do not want the set to contain 7. So that means 2, 3, and 7, right? 2, 3, and 7 are the only elements of U which does not belong to A, right? Now, the set of these prime numbers is this set, correct? When we are talking about the three prime numbers 2, 3, and 7, its set is going to be represented by this, right? Now, let's try to understand. Here you have three sets. One is U, one is A, right? And let us consider the set containing these three elements to be B, right? So you have three sets here, U, A, and B. Now there is a definite relation between these three sets. Universal set is something that we have already studied, that it is considered to be a set having all the elements or all possible elements which are there in the context of the problem or context of the question, right? So here we have three sets, U, A, and B. Now if you see, you have set A which does not contain the element 2, 3, and 7. And on the other side, you have another set B that does contain the element 2, 3, and 7. So that means if you combine, if you take the union of these two, that means B and A, there are 2, 3 things very obvious here. The first obvious thing is the intersection between A and B is a null set, right? Because there is nothing common between the two. The second is the union of the two sets, A union B, will give you the universal set U, right? That means if you take the union of these sets, you're going to get the U itself. Now, once these two statements are true, that means A intersection B is phi and A union B gives you the universal set, then you say that B is the complement of A with respect to U. So the important point to note here is, whenever we are talking about complement, there has to be a universal set defined. If the universal set is not defined, then it is very difficult for us to find the complement, right? Because complement is always found with respect to the universal set, right? So you need to have the universal set defined. And how do you define the complement? So two sets are going to be complement of each other if they do follow these two properties. That means the intersection of the two sets should be a null set, and the union of two sets should give you the universal set, right? And this complement of a set is usually denoted by A dash. That means we denote this complement of the set A as A dash. So whenever you have this A dash written, you have to be very clear in your mind that this is nothing but the complement of the set A, right? And as A dash, you can clearly write it as X, X belonging to U and X does not belongs to A. That means this complement of set A is going to have all the elements which are not there in A and which are there in U. Now, since we have also studied about difference of sets, this could also be represented as A dash is a set or collection of all x's such that x belongs to U minus A, because you want to include the elements of U, but you do not want to include the elements of A, right? So in set form, you can also say that A dash is going to be equal to universal set minus A. A dash is also going to be equal to universal set minus A. That means the difference of universal set and A, right? Now let's go to the formal definition. So the formal definition says that let U be the universal set and A be a subset of U, then the complement of set A is set of all elements of U which are not the elements of A, right? And symbolically, we write it as A dash. This is what we have been discussing so far to denote the complement of A with respect to U, right? And we have also seen that A dash is nothing but U minus A. That means the difference of universal set and A, right? Okay, let's move ahead. Let's see some examples. So the first example is let U be, or the universal set we have defined is this set, right? And set A is given as this. Now we wanted to find A dash. Now as we have discussed already that A dash is going to be a set which does contain the element of U, but which does not contain the element of A. That means you have to find U minus A. That means you have to cross out all the elements of A which are there in U. So you have 1 here. So 1 is something that cannot be an element of A dash. You have 3 here, 3 gets crossed out. You have 5, 7 and 9. So 5, 7 and 9 gets crossed out. So now the complement of set A is going to have 2, 4, 6, 8 and 10 as your answer, right? Let's see another example. The next example is let U be the universal set of all students of class 11th of a co-educational school and let A be the set of all girls in class 11th. So you had U as all the students of class 11th. So all the students consists of boys as well as girls, right? And you have set A as set of all the girls. Then A dash will be what? So that means your universal set had both the boys and the girls, and your set A has only the girls. So the A dash will have only the boys inside the class, right? Okay, now let's see what this note says. So it says that if A is a subset of universal set U, then its complement A dash is also a subset of U, obviously, because A dash is basically made by the elements of U and taking out the elements of A inside U, right? So since A dash is nothing but U minus A, and U minus A basically consists of all the elements of U which are not there in A, so that means A dash still contains the elements which are there inside U. So your A dash will have to be a subset of U, right? Now the second point is, if you find complement of a complement, if you find complement of a complement, so complement of a complement will give you in set builder for elements of U and elements not included in A complement, right? Elements of U and elements not included in A complement. That means your A complement will be U minus the elements in A complement, right? U minus A complement. And this A complement is something that we have already written as U minus A, right? So this becomes U minus A. Now if you'll see, this U gets cancelled and the ultimate value that you are left with is A itself. So that means we can say that complement of a set will give you the original set itself, right? Okay, now we want to find the results of A union B complement and A complement intersection B complement in this following example. So let's try to find these values. So you have been given U as your universal set, A is there as a set and B is there as another set. So first you have to find A complement. So let's try and find A complement first. So A complement, you'll remove all the elements of A from U. So 2 and 3 are going to be removed. So you have 1, 4, 5 and 6, correct? Then you have B complement. So you remove all the elements of B from U. So 3, 4, 5 gets removed. 3, 4, 5 gets removed. So you have 1, 2 and 6, correct? Now you want to find A complement intersection B complement. That means we want to find the element which are common between these two sets. So A complement intersection B complement is going to be the common elements between these two. So the common element is 1 and 6. So common element is 1 and 6. Now you also have to find A union B complement. A union B complement. So let's try and find A union B first. So in A union B, this set will have all the elements which are there in A as well as all the elements which are there in B. So you'll have 2, 3, 4 and 5, correct? So this is A union B. Now if you want to find the complement of A union B, that means you have to remove these elements from the universal set. That means 2, 3, 4 and 5 gets cancelled. So you have 2, 3, 4 and 5 gets cancelled. That means you have only 1 and 6 in your A union B complement. Now the important point to note here is, clearly in this example, you can see that A complement intersection B complement and A union B complement gives you the same value. So from here we can conclude that in this case, your A complement intersection B complement is going to be equal to A union B complement. And this is true always. This is always true. Not just that this is true for this example, but it is true for any example. So we will see that there is a rule also which governs this conversion. But still, we should be clear that A complement intersection B complement is basically equal to A union B complement. In order to remember it, it is very easy. So we'll remember it from this side to this side. So you have A union B complement. So this complement gets translated to A and B. So you have A complement and B complement. And whatever the symbol you have in between A and B, it gets interchanged. That means if you have union, the new symbol will become intersection. And similarly, if you have intersection, then the new symbol will become union. That means from here, one more result we can remember. That is, if you have A intersection B complement, then this value will now become A complement union B complement, right? So this intersection gets interchanged with union, and here this union gets interchanged with intersection, right? So this is something that we should always remember, these two results, because it is going to be very important for us to solve questions, right? So this is something that we should remember. In terms of in English terms, you can clearly see that the complement of union of two sets is the intersection of their complements, and the complement of intersection of two sets is the union of their complements, right? So we should always keep this in mind. And these laws, as I said, are basically from a special law that is called De Morgan's law, right? So these two are basically the components of De Morgan's law. So always keep this in mind. The De Morgan's law is basically derived from the name of the mathematician De Morgan, who actually invented it, right? Okay. So the complement of A dash of a set A can be represented as in Venn diagram form. The complement is basically all the elements which are not there in A. So we have left this vacant, and then we have selected all the elements which are outside the set A, right? So this is how we represent in a Venn diagram. Okay, so some common properties of complement of a set. A union A complement will give you the entire universal set. From here you can clearly see. So you have A complement as the shaded region and A as this region. So if you take the union of the two, you'll get the entire universal set, right? The second is A intersection A complement is phi. It is something that we have already established when we are studying this, because we knew that B was the complement of A and A intersection B was a null set. So clearly this is also established that A intersection A complement is a null set. De Morgan's law is something that we have studied right now, that you have complement of a union of two sets is basically intersection of their complements, and complement of intersection of two sets is the union of their complements. Law of double complementation we have studied, and law of empty set and universal set is that if you take the complement of empty set, you'll get the universal set, and you'll take the complement of universal set, you'll get the empty set, right? Now, once it is clear, let's try and solve the questions of exercise 1.5, right? Okay. So you have your universal set, you have set A, set B, and set C. First, you need to find A complement. So A complement must be very easy for you. Just remove all the elements 1, 2, 3, and 4 from this universal set. So you'll get your answer as 1, 2, 3, 4 removed, 5, 6, 7, 8, 9. So you have 5, 6, 7, 8, and 9, correct? B complement, remove all the elements of B from universal set. So 2, 4, 6, and 8 gets removed. So in B complement, you have 1, 3, 5, 7, and 9, correct? Then you need to find A union C complement. So A union C. A union C A union C. So you have to find A union C first and then find its complement. So let's try and find what is A union C. So A union C will have all the elements of A as well as elements of C. So you will have 1, 2, 3, 4, 5, and 6, correct? And if you take its complement, then you have to remove all these elements from U. So A union C complement will be all the elements other than these from you. So 1, 2, 3, 4, 5, 6 gets removed. So you have 7, 8, and 9, correct? Then you wanted to find A union B complement. So A union B, first you have to find A union B. So A union B will have all the elements of A as well as the elements of B. So you are having 1, 2, 3, 4 here, 2, 4, 6, 8 here. So A union B will be 1, 2, 3, 4, 6, and 8, correct? And A union B complement will be remove all these elements from the universal set. So 1, 2, 3, 4, 6, and 8 gets removed. So you have 5, 7, and 9 remaining. So 5, 7, and 9. So this is A union B complement. A complement will give you A itself, right? B minus C complement. So first you have to remove all the elements of C from B. So first we will try to find B minus C. So B minus C, remove all the elements of C from B. So 4 gets removed and 6 gets removed. 4 and 6 gets removed. So you have 2 and 4, right? And now if you want to take its complement, so B minus C complement will be all the elements in U other than 2 and 4. Other than 2 and 4, so you have 1, 3, then 5, then 6, 7, 8, and 9. So this will be your answer, right? I think it should be very easy for you. All right. So U is this set, then find the complements of following set. I think this should not be very difficult for you. Remove A, B, C from here. So you have D, E, F, G, and H as complement. D, E, F, G, remove D, E, F, G from the universal set. So you have A, B, C. D, E, F, G gets removed. So you have H, right? C, again you have to remove A, C, E, G. So A, C, E, G gets removed. So you have B there, D there, and then E gets removed. You have F there and H there, right? You have F there and H there, correct? Then you have F, G, H, A. F, G, H, A, remove F, G, H, A from here. So you have A, B, C, D. Sorry, A gets removed. So you should not be having A. So A gets removed, so you have B, right? C should be there, D should be there, E should be there, F gets removed, G gets removed, and H also gets removed. So this is your answer, right? Taking the set of natural numbers as universal set, write down the complement of following sets. So X is an even natural number. So you are removing from the set of natural numbers all the even natural numbers. So your answer should be set of all odd natural numbers. And when you are removing all the set of odd natural numbers, so your complement should have only the even natural numbers. X is a positive multiple of 3. So you are removing all the positive multiples of 3. So you can say that your complement is a collection of X, right? Your complement is a collection of X such that X is not a multiple of 3 and X is a natural number, correct? Because you are finding the complement from the set of natural numbers. X is a prime number, so your answer should be X, where X is a natural number and X is not prime, right? So this will be your answer. X is a natural number divisible by 3 and 5. So that means you are only removing the elements which are divisible by both 3 and 5. So any number which is divisible by 3 and divisible by 5 has to be divisible by 15, right? So here you will have X, where X is a natural number and X is not divisible by 15, correct? So this will be your answer. X is a perfect square. So again you will have X belongs to natural number and X is not a perfect square, right? So I think you'll be able to answer all the remaining ones. If you have any issue in answering any one of the following, do drop a message and I'll get back to you with solution of those questions. Right? I don't think that we should be having any trouble finding this as a solution, because this is nothing but the De Morgan's law, and we have already established De Morgan's law using an example above, right? Now let's go to the next question. So the question is, draw appropriate Venn diagram for each of the following. So let's try do it on a fresh page. So I'm going to add a page after, right? So let's take a dotted page. All right. So here you wanted to draw A union B complement, right? A union B complement. So let's draw the rectangle first, representing the universal set. So here we are trying to find A union B complement, right? Okay. Now let's draw two sets, A and B. So let's use a different color. So here you have one set, here you have another set, right? So this is A and this is B. Now A union B should have been all the elements which are there inside these two, right? So this should be A union B. But we are not trying to find A union B. We are trying to find A union B complement, right? So we will have to include all the elements which are not inside the union. So everything other than this. So let's use a different thing to color this. So let's use this. So what I'll do is I'll color all the sections which are not inside either A or B, right? So this shaded region is going to be your A union B complement, right? Let's try to see the next one. We wanted to find A complement intersection B complement. Since we know that these two are equal, so we are not going to draw another Venn diagram for this. Similarly, A intersection B complement, right? So A intersection B complement, let's try to find out A intersection B complement. So we are trying to find A intersection B complement, right? So let's draw the universal set first. So this is your universal set. Let's draw the two sets. Suppose this is set A, this is set B, right? So this is set A, this is set B. This one is this section. This section here is the intersection, right? This section here is the intersection. But we want the complement of this intersection. That means we want everything other than this section. So if we try to shade the region, we have to exclude this section, right? Exclude this section, and everything other than this section is going to be inside our required set that we have to form. So this is going to be your resultant set that we want. So this is the Venn diagram corresponding to it, right? So everything other than this region is going to be your required set. Now the fourth one is, since we know that by De Morgan's law these two are equal, so these two, the Venn diagram corresponding to these two is going to be same. All right. The sixth one is, let U be the set of all triangles in a plane if A is set of all triangles with at least one angle different than 60 degree. So when I say at least one angle different than 60 degree, that means we want, see this statement is something that we have to get an idea of, that what exactly is this statement. At least one angle different than 60 degree. That means we want not all angles to be 60 degree, right? We do not want all angles to be 60 degree. That means we do not want our triangle to be equilateral. So this is the set A where not all angles are 60 degree. And we wanted to find the A complement. So A complement is going to be set of triangles with all angles as 60 degree, right? Because we do not want any such triangle whose all angles, not all angles are 60 degree. That means we want all the set of triangles whose all the angles are 60 degree. So your A complement is nothing but X, where X is a set of equilateral triangles, because your all angles should be equal to 60 degree. So your A complement is set of equilateral triangles. Okay. Now A union A complement, we know that this is universal set. Phi dash is nothing but universal set itself. So phi dash intersection A. If you take intersection of any set with the universal set, you are going to get the set A itself. A intersection A complement, we know that this is phi. U complement is nothing but phi. And if you take intersection of any set with phi, you are going to get phi as your answer, right? Okay, now let's see some miscellaneous examples. So show that the letters needed to spell cataract and the set of letters needed to spell tract are equal. So all you need to do is you need to form a set of unique alphabets from this. So say if this is a set X, so you have unique alphabets as C, A, T, and then A is already included. Then you have R, A is included, C is included, and T is included, right? So this is your unique set of alphabets from this letter. And from tract, if you want to find Y, so you have, sorry, you will have to write capital letters for the set, right? So here you'll have T, R, A, C. T is already included. Now if you see, these two are clearly equal, right? Let's move ahead. The example 24 is list all the subsets of the set this. So since there are three elements, we knew that we have already studied that the number of subsets is going to be equal to 2 to the power number of elements in the set. Here the number of elements is 3. So the number of subsets that you are going to get is 8. And what are those 8 subsets? So first you'll have the empty set, because it is a subset. So if we want to write all the sets here, the first subset is going to be the empty set. The second subset is going to have only -1 inside it, then 0 inside it, then 1 inside it. Then you'll have 2 elements in each of the sets. So once you have -1 0, then -1 1, then 0 1, and then you'll have the set A itself, that means have all the 3. So all the subsets are phi, this one, this one, this one, this one, this one, this one, and the set A itself, right? Now you have show that A union B is equal to A intersection B implies A equal to B, right? So that means A union B is equal to A intersection B. That means union of two sets is giving you the intersection of two sets, right? So this is only possible if A is equal to B. Now let us see how. Here we will use the mathematical way of coming to a conclusion. So let us say we have a random element A which is there in set A, right? So then A belongs to A union B, because since A is an element of A, it has to be there inside A union B, right? And since A union B is equal to A intersection B, that means A has to be inside A intersection B. Now, you have to put little bit of extra care and extra importance here, because this is a very good way of, reaching to this conclusion. So we started with a variable element. This variable element could take value of any of the elements which are there in set A. So do not consider this small a to be the only element of set A. Consider this to be a variable element, right? And this A can assume any value which basically corresponds to one of the elements of this set A. It could be anything. any value, right? So we have considered a variable element which is there inside set A. So since A union B is a set having all the elements of A and B, and if A is an element of A, then A has to be element of A union B. And from the statement given here, we know that A union B is equal to A intersection B, right? So that means if A is there in A union B and A union B is equal to A intersection B, that means A has to be there inside A intersection B, right? And intersection is nothing but the set of common elements between the two sets, right? So if A is there inside the intersection, A has to be there inside set B, right? That means A was there in set A, also A was there in set B. So we can say that A is a subset of B, right? Because all the elements corresponding to set A are there inside set B. But this still does not prove that A is equal to B. This only proves that A is a subset of B, because all the elements inside set A are there inside set B, right? So that means A is a subset of B. Now let's start with a variable element inside set B, right? So a variable element inside set B. So let the variable element be small b. Now if B is an element of B, so clearly it has to be there in A union B, right? And if it is there in A union B, because of this statement, it has also to be there inside A intersection B. And when it is there inside the intersection, that means it has to be there in A as well as there in B. So that basically gives us the conclusion that B is also an element of A. Now let's see. We started with a variable element of B, and we concluded that this variable element is also there inside A. That means all the elements of B are going to be there inside set A. So this will give you the conclusion that B is a subset of A. Now you have two conclusions. A is a subset of B and B is a subset of A. And we know that if A is a subset of B and B is a subset of A, this gives you the conclusion that A is equal to B. So this is how you prove it, right? So without getting into too much of Venn diagrams and everything, just by a simple mathematical statement, we can prove that if A union B is equal to A intersection B, you'll have A is equal to B. All right? Okay. Now let's come to the final section of the chapter, that is the miscellaneous exercises on chapter 1. So first question is, decide among the following sets which set are subsets of one and another. So here you have set of all the x's which are real and satisfy this equation. Since we know that the solution for this equation is nothing but 2 and 6, right? So let's write it like this. You have B as 2, 4, 6, you have C as 2, 4, 6, 8 and so on, and you have D as 6. Now let's see. A is clearly a subset of B. A is a subset of B. Also, A is a subset of C also. So A is a subset of C, right? B is a subset of C because all the elements of B are there inside C, right? And also D is going to be a subset of both, in fact, D is a subset of A, D is a subset of B, D is a subset of C, right? So you have D as a subset of A, D as a subset of B, and D as a subset of C, right? So this is all the subsets that you are going to get from this, combination. Okay. In each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. All right. So the first statement is, if X belongs to A and A belongs to B, then X belongs to B. So this is a false statement. Let me tell you how. Suppose if we have a set B given as 1, 2, and 3, right? So this is a set. Here A represents this set, right? So clearly you can see that 2 is an element of A, right? 2 is an element of A. the set A itself is an element of B, but 2 is not an element of B. 2 is not an element of B, right? Here 2 is not an element inside B. Rather, the set containing 2 is an element inside B. So this is a false statement. The second one is, if A is a subset of B and B belongs to C, then A belongs to C, right? Let's see an example. A has been given a subset of B. So suppose A is given as this set. It is a subset of B. So let us say B is a set containing 1 and 2, right? Now B is an element inside C. So C, say, suppose have elements as 3, 4 and this set B, right? So this is your set C. So all the relations are satisfied. A is a subset of B. B is there inside the set C as an element. Now, do we see that A is an element of C? No, it is not. Because the entire set B was an element of C. And had this statement been true, that is A is a subset of C, in the set C, you should be having this set as an element. But this set is not present inside set C as an element, right? So this is also a false statement. Then the third one is A is a subset of B, B is a subset of C, then A is a subset of C. See, all the elements of A are there inside B because A is a subset of B. All the elements of B are there inside C, right? So all the elements of A has to be there inside C. So this is very true, right? A is not a subset of B. B is not a subset of C. Then A is not a subset of C. Now this cannot be true. Let me give you an example. Suppose A is a set having 1 as an element. Suppose B is a set having 2, 3 is an element, right? And suppose C is a set having 1, 4 and 5 as an element. Now let's see. Is A a subset of B? No. Is B a subset of C? No. But is A a subset of C? Yes. So that means this is a false statement. Okay, now let's see the fifth example. The question is, if X is an element of A and A is not a subset of B, then X is an element of B. Now let's see an example. Suppose if A is a set having elements 2, 1 and 2, right? And suppose B is a set, right, having 1, 5 and 6 as an element, right? Now if you see, A is not a subset of B because had A been the subset of B, both of its elements should be there inside B, right? But the both elements are not there inside B, right? Both elements are not there inside B. But one is an element I can clearly see in both A as well as in B. That means this statement can be true, right? Let's see the sixth one. If A is a subset of B and X does not belong to B, right? Then X does not belong to A. See, A is a subset of B. That means A has only those elements which are there inside B. Because any subset that you form, has to have an element of B, right? And when X is not there inside B, you cannot have that element inside A. That is for sure, because A is a set that has been constructed from the elements of B. And when the element is not even there in B, how can it be there in A, right? So if X is not inside B, then X cannot be inside A. So this is again a true statement, right? Okay, for the other remaining questions, since most of these questions are in form of statements which we have to prove, so what I'll do is I'll include all the solutions for these questions which are you know which are in nature asking for you to prove the truth of a statement. So what I'll do is I'll solve these questions in the next set of video that I'll put here, right? So what we have done here today in the class, that we have studied about complement of a set, and then we also studied about De Morgan's law, right? And we solved some questions. The remaining questions of the miscellaneous example, that is from 3 to 10, will be included in the next video, which is going to be in the series. So that will be the last video, and we'll have all the solutions from question 3 to 10. Okay, see you in the next video. And till then, you keep studying hard, keep working hard. I hope these series of lectures from SET would have cleared any sort of doubt which is there in your minds, and must have helped you to understand and grasp the concept of sets in a much more elaborate way. And you also need to understand how exactly it is going to shape up the other, chapters which are about to follow. The second chapter itself will be studying about relations and functions. So there also we will be using some concepts of sets that we have studied here. Okay, see you in the next lecture. Till then, have fun learning and be confident. Thank you.